This is the SOS video of working on Unit 12 practice problems. So Unit 12 was about exponential decay and growth. As a reminder of all the concepts, you should go back to the other SOS videos. These are just going over a few practice problems. Typical mistakes people make, they forget that the rate is how far away from 1 the factor is, and we'll talk about that a little bit later. Exponential equation is y equals ab to the x. A is your initial amount, what the situation was before anything happened. And b would be our ratio or factor, the entire number in parentheses. So first step, contrast the graphs of these two functions. Well, what you know is that each of them are increasing because as long as the number inside the parentheses is more than 1, it's going to be increasing. That the number in front is your initial amount or your y-intercept. So this one would have a higher y-intercept than this one. Initial amount, y-intercept. They are both increasing, but this is increasing at a faster rate. If I am multiplying each term by 3, the terms are going to increase much faster than if I'm multiplying it by 2. They both, the compare part is they both will have a curve. They're both exponential equations. And you can always put these on your calculator and look at the graphs to see exactly how they compare and contrast. All right, explain what this graph will look like. Well, it's going to be a curve. It's going to have a y-intercept of 10. Since this number inside is less than 1, it's going to decrease. That means its factor is 1/5. And how can I check to be sure? Go right to your calculator. Okay, go to y equals, put in 10, let's see, alpha y equals, and to the x power, and let's press graph, see what happens. And sure enough, this is a curve. It's decreasing, it's going down. This is right at the very top because remember our y-intercept was 10. And even though it looks like it's touching the x-axis, it never will. This will never get down to 0. And the way I check that is I can look at my table of values. Get smaller and smaller. This means 10 to the negative 8th power, but this y value will never equal 0. Okay, number 3, population is increasing at a rate of 4%, which is 0.04. What is the growth factor? So when it's growth, I'm going to say 1 plus my rate, which means it's 1 plus 0.04, which means it would be 1.04. All right, a store is losing 2% of its business each year. So losing means it's decreasing. 2% as a decimal, 0.02. What is the decay factor? I start with 1 and I will subtract my rate. So I have 1 minus 0.02, or that becomes 0.98. And that would be in the parentheses. Okay, if 72 wolves are introduced to a park preserve with the expectation the population will increase, so that's going to go up, 7% each year, 0.07, write the equation to determine how many wolves will be there in X years. Okay, so we can start off with y equals, because they didn't tell me another variable to use for that. My initial amount was 72 wolves. Since it's increasing, I'm going to have a growth factor of 1 plus my rate of 0.07 to the time factor is X years. That would be sufficient. If you wanted to do the math inside, you could write it like this. And that would be the equation I could use to determine how many wolves will be there, no matter how many years you ask me about. Okay, this is a table of an exponential function. You probably would have recognized that right away because it's obvious we are not adding the same amount to go to the next term each time. Just for curiosity's sake, what is my common ratio here? Remember, we can take a number, a term, and divide by the previous one. 36 divided by 12 is 3. 12 divided by 4 is 3. Let's make sure that works for everything. So 2,916 divided by 972, and that will also give me 3. But you aren't asked to find that. What you are asked to find is the rate of change over the interval 3 is less than or equal to x is less than or equal to 7. So this is my starting point, and this is my ending point. Whenever you're asked to find the rate of change, you have to know what your starting point was, which is this one, and what our ending point is, which is this. I find it easier to write it as an ordered pair, and then just remind myself what's x and what's y. So remember, our rate of change is change in y over change of x. You're going to take one of the y values, subtract the other one, and go back to that same point, take the x value, and subtract the other one. So I could say this is x1, y1, x2, y2. And that's it. Now let's just subtract these numbers. 972 minus 12 over, I have to come back to this point, 7 minus 3. Well, that gives me 960 divided by 4, and that gives me 240. So my rate of change over this interval would be 240. All right, and our final question, is it linear or exponential? Remember, linear is when I am going to be adding the same amount, same exact number each time. Exponential is when I am going to multiply by the same number. Very different things. Okay, medicine decaying by a factor of 1/3. So factor tells me I'm multiplying, so right away this is my exponential. Paying off a loan, $320 a month. So if I'm paying $320 a month, that's the same amount each month. That's a linear. Accumulating 5% interest on a bank account. I'm not adding the same amount. I'm multiplying by 0.05, the 5%, so that is exponential. Driving 26 miles each day to work, I am adding the same amount to my mileage every day, 26 miles, and that is linear. So this was practice problems for your Quarter 3 assessment on Unit 12.